Okay, so welcome back, and we're still advancing in the first exam from the 2015 fall semester. And I'm so sorry about that. I still didn't finish it. I'm probably just. It feels like I had so much stuff to going on, but actually I'm probably just procrastinating. Never mind. And it says we're on question number 23. It says which of the following is in the order of increasing bond length. So in molecular geometry, like the bond length is defined by the like I should do something like this. Like the bond length is defined between the two nuclei of the atom, like the distance between the two nuclei of the atom. And so like it's related to the size of the atom, and if you remember the general chance of the size, so I just draw like a somewhat periodic table real quick. uh, So this is a periodic table, and if you remember from your class, the size the the size increases from top to bottom. So this is bigger, and this is smaller. Size. Let me just write down so this is size of atom, and they're usually bigger on this corner and small on this side. So the reason why this is from smaller to bigger is because usually I'm missing hydrogen over here. So what the reason why it's in this kind of arrangement is because usually the one on the atoms on the lower side of the on the lower side of the periodic table has more electrons and more protons and everything. So they're like generally bigger atoms. So they're just more electrons, more. So they're just bigger atoms by, I don't know, by nature. Like they're just having more stuff going on around them. So they're generally bigger. And the reason why it's smaller on the right side and it's bigger on the left side is because the thing on the right side over here, like they have more nuclei. They have more protons in the nuclei, which result like a stronger effective nuclear charge. So stronger effective nuclear charge, which like kind of like pulls the electrons around them, so make the atom smaller as they are. That's why it's in this kind of arrangement over here. So this arrangement over here. So now we got this trend, and let's take a look at the problem. So that we got hydrogen, uh, carbon fluorine bond, carbon sulfur bond, and carbon chlorine bond. And apparently, so fluorine is on this corner over here, and chlorine is under it, and sulfur is somewhere around. I believe it's over here. So let's think about that. According to this trend, so fluorine would definitely be the smallest atom among all. And then I would say because so those two are in the because it's on the top left corner, and the trend usually goes like this. And chlorine is on the right side of sulfur. So chlorine is supposed to have a stronger, more according to this rule over here. Chlorine will have more protons in the nucleus, and attracts the electrons to be smaller than the sulfur. It has a stronger effective nuclear charge. So sulfur, and then I'm sorry, it's chlorine and then sulfur. So that's why the bond order in increasing bond length will be carbon fluorine bond, smaller than a carbon chlorine bond, smaller than a carbon sulfur bond, which is the gives us answer D over here, and we're in here.